Hi there, this is Jacob Nash, and in this video, we're going to be talking about how to solve some of the problems that are tricky for finding limits of sign problems where you have issues in the argument. And if that doesn't make sense, you'll just know what kind of problems I'm talking about when I do it. So the first thing that we're going to say is this. We're going to know that this is true. For some versions of a calculus class that you may take, this isn't something that you'll just be told. But in this case, yeah, this is just true, okay? We're going to just say that. So we got to remember that when we have the limit of where x goes to 0 of sine x over x, it is 1. And we're going to use that to find other or solve other problems. So let's just look at an example to start. Okay, so what is this problem? Like, you might just be tempted to be like, oh, it's 1. Well, I actually have to say that is the answer, but that's not the way that we do it, unfortunately. You have to do something more complicated. Now, here's what we do. You pick any letter that you want that's not x. Probably you wouldn't want to do y either. How about we're just going to choose the symbol theta, because that's pretty common in trigonometry, so we're just going to use this, okay? Doesn't matter what you use, but this is just what I'm using. We're going to say let theta equal, and then every time we do this, we just put whatever that is. So we're going to say it equals 2x. The next step is to take this part and put it over here. So we're going to be like, okay, x goes to 0. Now we have to make it to where this looks like this. And we just do that by multiplying by 2, right? We also have to do that on the other side. But obviously that doesn't matter because that still is this. Now we can say replace 2x with theta, because up here we established that they were equal. And now this is good that we have this, because now we're going to take the limit as 2x approaches 0, which we're just calling theta, and the whole point is that you're not allowed to have something like 2x right there. That's why we had to create this symbol. And we had to establish that it all is going to 0, and we're not changing anything. And we have to do that so that we can get rid of this 2x and instead actually be able to solve. So now we're going to instead write this. The limit as theta goes to 0, and we just replaced the 2x's with thetas. Now it looks like what we had at the beginning. There's just thetas instead, and we can say that it's equal to 1 now. So that's how you solve it. It's a little bit weird, but after you do it like 3 times, then you'll get used to it. But we're going to do some more examples that are a little bit more complicated, so we just have some practice. Okay. Sorry about that. Okay, well, what if we have something that's a little bit different, like this? Well, once again, looking at this, you might just be like, oh, it's 1. And once again, yeah, it is 1. But you know how calculus is. Like, at this point, you probably have realized that you have to do things a certain way. You can't just take the easy route. You have to prove things. So we can't just do that. Once again, we'll do our theta thing. So we're going to say let theta equal, and this time we're going to say x minus 1. Now, once again, we just take this thing and we put it, what? Okay, sorry. We put it right here. Oops. Yeah, sorry. Put that right there. We need this to look like this, so all we do is subtract 1 on both sides. Now we have this, and we can now say this because of this statement up here. This thing erases kind of slow. Now we'll just say this. We can replace that with theta. Once again, it equals 1. So that's all we're doing when we do this. We're just being like, move out this stupid stuff and put it right here, kind of. So it's not really that complicated if you think about it. We do have some crazier examples, but the only reason why they are is you just have to know your trig stuff. So, let's do this now. All right, obviously that's a little bit crazier than it was before. But fortunately, the thing that we're able to do is we know our limit laws. We're able to separate this and from this. And it looks like we can see here we have two things that are the same like that. So that's how we might know we can use the process that we're doing. So what is the limit as x approaches 2 of 3/2? It's just 3/2. So we can just go ahead and put this off to the side and know that whatever our answer is, we'll multiply it by 3/2. So, and you know, you should show your work, so technically I should be like, I'll do that in a minute, okay? So now we're going to once again say let theta equal 0, or not 0, sorry. Let theta equal x plus 2. We put this here. We make the x, we have to make it x plus 2, so we do the same thing to both sides. Now we have x plus 2 goes to 0. Theta equals 0. So now we're going to do two separate limits. We're going to have the limit as x approaches -2 of 3/2. We're going to have the limit as theta approaches 0 of sine theta over theta. This turns out to be 3/2. Anytime you take a limit of just a number, it's just a number. So even if you had pi, that's always important. Like people might get confused, it's just pi. But this is just 1, so the answer is 3/2. Look at that, not actually as complicated as you might expect. Okay, got just a couple more to do. Let's see here. What's a good one to do? Okay, here's a good one. Limit of x, or limit as x approaches 0 of tangent x over x. Ooh, what do we do? Anytime you have a problem where you don't know what to do, the first thing you should think of is, I'm probably gonna have to change something to make it look like something that I do know how to do. We don't know how to do things with tangent, but are we able to do something to tangent to make it look like what we just did? Yes, because hopefully it is very good to know your trig identities. I have a video on that if you need that, but tangent of x is going to equal sine x over cosine of x. I always just remember, like, I don't like my trig identities, so I say tsk, TSC. I don't know, that's the way I always remembered it. So tsk, don't like your trig identities. So we're going to change this to make it look like what we know. So we're going to be like, goodbye. Now we just have sine x up here, and then we have cosine. Here's where you might make a mistake. Here's where it's probably good to have parentheses too. Don't forget that that x wasn't a part of the situation there, so we have to have him right there. That's something that could make you get mixed up. So now we do the usual thing. We can actually separate them into two limits. Like technically we'll just do 1 times. We'll have a limit here, and then also take a limit of this. That's what we'll do. So we're going to do what we've done before. We're going to say let theta equal this time. Oh, never mind. What? Sorry about that. Actually, you don't have to do that because it's already just x. So easier than that. We'll take the 2 separate limits. Don't even actually have to do that. Never mind. You don't have to do that. We're just going to do this. We'll do it like this. All right, well, if you plug into 0 right there, what happens? Cosine of 0, not theta, sorry, 0 is 1. Sine of 0 is 0. Tangent of 0 is 0. Think about why. If you plug in a 0 here, plug in a 1 here, it's 0. So that doesn't even matter though. This is what we're thinking about right now. So we're 1 right here, 1 right here. That's just the rule I talked about at the beginning. 1. There you go. Not so bad, right? Now, we're going to do this one. That doesn't look fun, does it? That looks stupid. Well, like I said, don't know what to do, make it look like something you do know how to do. Cosecant of x is 1 over sine of x. And if cosecant is in the denominator right here, then if it equals 1 over sine, then we can actually say hello and put the sine in the numerator. That's just the way that it works, because if we replace this with 1 over sine, it's a fraction divided by a fraction, which you just flip it over. So this guy is going to be in the numerator. So now that doesn't look so bad, right? We see that this looks like what we've been doing in the video, and then we don't even have to worry about this guy because he's just a simple limit to take. So I'm gonna let theta equal 2x. So then we put this. Once again, limit theta approaches 0. We just replace all the 2x's with theta. No, I'm sorry, that's actually wrong. I made a mistake there. So the cosine is not included in this part, so that's where we're going to have to take 2 limits and just know our multiplication that we can do that. If we, right here we can just do direct substitution. 2 times 0 is 0, cosine of 0 is 1. This part, we would just want to do this. And we know that's 1. So 1 times 1, answer is 1. I don't know if there's like a clear all on this. That would be nice. Okay. We have one more example that we're going to do in this video. Limit as x goes to 0 of sine of, oh, I wrote it slightly too high, pi over 4 plus x times sine of 4x all divided by 4x. Okay, well, we could see that this looks like, anytime you see things that are the same like that, that's how you know that we can do that, this rule. And this guy is going to be like this separate, like the cosine in the last problem, like he's not a problem if we plug in 0. So we don't have to worry about that. We're going to do our usual thing. We're going to let theta equal 4x. I'm just skipping a step, it's going to end up being that. So once again, we got to do 2 limits. We'll start out with this one. We know this is 1. Now what about this part over here? Plug in 0. What is sine of pi over 4? Unfortunately, that's just one of those ones that you're going to have to remember. It's root 2 over 2. So if this is the case, then the answer is root 2 over 2. So that's the end of this video. As you can see, this is kind of like a weird process, but not actually that hard. And once you do it a few times, it just makes sense. The hardest part is just going to be remembering all your trig identities and rules and unit circle, all that stuff, because they'll throw anything at you to make you get it wrong, unfortunately. So just got to know that stuff. And I do have videos on that, Jacob Nash pre-calculus lessons. I have some simple videos to explain that stuff. I think they were made in 2021, but still, not that old. So thank you for watching.